Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
And we're at ProgNet in the basement. The rooms here in London are named after keys on the keyboard.
Yes.
So they actually have a bar out front with coffee and wine and beer and stuff, and it's called the Space Bar.
Nice.
And then they have rooms Control, Alt, Shift, and we're in the room in the back of the building, and it's called...
Backspace.
Backspace.
It's a good little room. You know?
It's the Backspace.
Yes, it is the Backspace.
It's really cool.
It's correctly named.
Yeah, it's cool. So we're having fun here. Clemens Vasters, our old friend, is here. He was doing a keynote, and we'll probably be talking to him about what he was talking about, right? Mm-hmm. And but before we do any of that, we have this little matter of better know a framework.
Oh,
roll the music.
All right, dude, what do you got?
Well, in honor of our German friend, I have some software that you can connect to your BMW to do all sorts of diagnostic stuff.
Oh, my.
If you've never done this before, there's a standard computer jack that all cars come with now. And I have a NavD heads-up display. So this connects to that thing, and it's very standard. And this is diagnostic software. It's BMW GT1 diagnostic software. It's about 40 pounds, or at least that's where it starts. And it works with just about every model of BMW. And here's what it says. This software package enables you to unlock the mysteries of your BMW's comprehensive diagnostic and complex electrical control systems and carry out virtually all of the tasks which would normally only be possible by making a trip with the car to a BMW dealer, including resetting service intervals and reading and diagnosing stored error codes.
Cool.
However, this diagnostic software is far more than just an error code reader. And I'll let you read the rest.
That's cool.
1484.pwop.me. And there's just, if you get this for one reason only, it's to check the error codes before you go to Jiffy Lube.
Right.
You know what I'm saying?
Or go for maintenance.
Or go for maintenance.
Yeah,
and when they say, yeah, you know, it's about time for you to change your transmission.
Yeah.
And you're like, oh, really? That's not what my computer told me this morning. Yeah.
Just to be more informed of what's going on in your car. Cars have serious computers in them these days.
They are computers
we
with
just
wheels.
Forget. Yeah.
Up to 40 microcontrollers.
Yeah.
Wow.
And so this app being a car specific, this standard jack has been in cars since 1997 because it had to be
OBD2, is that what it's called?
Yeah, OBD2, that's what it is. But the standard set is actually very constrained because it's only for emission control.
Right.
And then every manufacturer has their own secret thing. So these apps go and specialize on particular manufacturer because you can go and you can get those codes from the manufacturer handbooks.
Right.
Yeah.
But there's no big set where you can get them all.
And it's also good because sometimes an idiot light will come on and you have no idea what it means.
No, check engine, right? It could, it could be a million things.
It could be a million things, right? Yeah. So there it is.
That's cool, man.
Yeah. In honor of Clemens. So who's talking to us?
Grabbed a comment off show 1242, which is the last show we did with Clemens, called Messaging is Forever, back in January of 2016. Got a few comments on the show. This one's from Mark Janos, who says, "Hey, Clemens, thanks for the great show. We were there too, man." It was excellent to hear someone who understands both industrial protocols and web messaging and is working to bridge the gap between them. Although I agree with Carl that legacy industrial protocols do have security issues, we need to remember that until 5 years ago, and this is 2 years ago, right? Because last time you were on, we were only dealing with on-premises databases. And as a 20-year veteran of manufacturing and industrial automation, I'm super excited about public cloud and the possibilities opened up by centralized data assets. Looking forward to more shows on IoT messaging as the space evolves.
Yeah.
Well, very nice. Thank you, Mark. Kind words. Got to say them directly to Clemens. And we're pretty excited about all this too. We were when we did our talk this week about the development landscape, we kind of said less about IoT than we normally do. And one of the points was I feel like we're currently in the IoT is no longer new and shiny. It is work you have to do. Yeah. And we're doing the work. Yeah. And so it's not a lot of sexy going on. It's just doing work.
Yes.
And I like that. That shows the evolution and the maturing of a marketplace. So, Mark, thank you so much for your comment at .NET Rocks mug. It's on its way to you. And if you'd like a .NET Rocks mug, write a comment on the website at .NETRocks.com or via any of our social media, because we publish every show to Facebook and Google+. And if you comment there and we read it on the show, we'll send you a mug.
And definitely follow us on Twitter. He's at Rich Campbell. I'm at Carl Franklin. Send us a tweet. We calibrate them for maximum superiority.
I thought it was minimal emissions, but okay. I've been calibrating them wrong.
All right. And to formally introduce Clemens Vasters is a product architect for the Azure messaging platform, which includes Service Bus in the cloud, as well as Azure Event Hubs. He and his team also created Azure Event Grid, which we just talked to Dan about, Azure Notification Hubs, and Azure IoT Hub. Those are now with dedicated teams within Microsoft. He's participating in several standardization efforts, including guiding Microsoft's messaging engagement strategy in Oasis, and great band, by the way. And he is a member of the OPC UA Working Group and the OPC Foundation's Technical Advisory Council. Welcome back.
Hello, Carl.
Hey.
Hello, Richard.
Dude, that's a lot of hubs. How many hubs do we need?
Why so many hubs?
What's up with all the hubs?
Yeah, we have a lot of hubs. So the grid. Well, now we have a grid.
And you have a grid too.
Yes, yeah. So the hub is comes out of the naming is something that we are involved in, but we don't have necessarily say in. But yeah, we have a lot of stuff.
Right.
Very experienced in naming things.
I have yes, indeed, and I have meanwhile decided that naming discussions are discussions that I don't really want to participate in.
Yeah, that's fine. I don't
you guys
blame you.
Just let me know what you come up with.
Yeah, yes. I will go if they come out of the fight with 3 proposals. I will probably vote for one, but I don't want to be a part of the fight.
Right. Get it down to the 3. I'll happily weigh in.
Yes,
then.
because
So we talked about this with Dan a little bit, but maybe you can shed some light on it. These things happen in progression, and based on what exactly? Based on the current technology that Microsoft has to offer, based on architectural design, all of those things. I mean, why do we have all these options now for sending a message?
Yeah, so we have, let me enumerate the options that we have. So there's, outside of our team, there's Azure Queues, so that's part of storage. We have Service Bus with PubSub and queues. There's Event Hubs, Event Grid now as a new thing. We have the Relay. It's bridging connections. And then also we have the IoT Hub, specifically for device connectivity. We have Logic Apps that also moves data around in workflows and connects out to other systems.
Azure Functions might be a part of that.
Azure Functions that's kind of the far end compute part of that.
Yeah.
Right. So Logic Apps has kind of this dual function of being a compute host in a way, but also moving data around.
Yeah.
So there are all these different options, and there's a motivation for having every one of those. And if you ask, like, how do you get there? It's typically through observation of what customers do.
Right.
And a lot of conversations that we have, and often it's through support incidents, and support incidents not in the sense of something broke, but customers come to us, and this is a great function of the Azure portal site. That if you have a problem or if you are not sure how to solve something, you can always raise a service request with us, and you'll get help. And that happens. We have very skilled folks who are doing that support work every day and who know the product really well, so they'll help. But then if someone comes with something that's outlandish as a request, I need to hold a terabyte of data in a queue, and I need to drain it within 30 minutes. We've heard things like this.
Scary.
Then you can't dismiss it as crazy, but you have to go and start asking why that's so.
Sure.
Like,
why
are you asking something that is so special?
Well, I think that's the Microsoft response to just about everything that's, I want to do this. The question is, why would you want to do that? And that's a great question, because now you're getting their intent,
yes,
which is really something they may not be upfront about.
So the journey, for instance, towards IoT Hub started with the notion of how can I go and get getting data from devices is
pretty standard.
Pretty standard, right? Because you come in and you have a queue, and now we have these ingesters in the form of Event Hubs, and then in other spaces, Kafka, and you just drive the data in. The harder problem was, how do I get commands back to the devices?
Yeah.
And we've done an initial prototype, or I've done that, called Reykjavik, which was how do you configure Service Bus to be that channel to the devices?
Right.
And the reason why we needed a queuing mechanism for this was motivated by thinking about automotive cases. And automotive in that case was a fairly concrete discussion that was had with a car manufacturer.
Yeah.
And cars are made in very large numbers.
Yeah.
And so And the problem that was there to be solved was, cars go into tunnels and they lose coverage.
Right. They need to queue up that data.
Right.
And you need to, if you send a message to a car, that you can't rely on the connection being stable.
Sure.
Yeah.
So it needs to come and reconnect and basically get this message back. While it is connected, it should be lowest possible latency, but you should be able to queue up that message. So we needed to have something that is a queue-like thing.
Sure. Interesting side note. I noticed there's the tunnel in Boston on the Mass Pike that goes under the bay to Logan Airport. They must have antennas or something
they have what's called a cell cable.
Cell cable at a relay, because I never lose anything.
I have had a conversation in a taxi coming out of the airport going under the bay.
Yeah.
I was talking to my mother. I'm like, Mother, I am underwater right now.
Yeah, it's amazing.
So I'm still talking to you. She's like, we live in a science fiction novel.
So it's cool. You get that in places like Boston, but not every place is fortunate.
But it became pretty clear very quickly that Service Bus is the wrong vehicle for this, because we need little queues and we don't need big queues. And if you make a Service Bus queue or a Service Bus subscription, you get 5 gigabytes of storage with it, and it has all these transactional features, and you don't need any of those.
Right.
So we started with a prototype. The prototype was fairly successful in that it actually ended up being used in, or still actually is used in production in some places.
Right. Mm-hmm. But I got to think, when you start to scale, all of that extra stuff becomes costly.
Yes. So we needed to have something that could easily do 10 million of these little device queues.
Sure. Different problem.
And now that causes a new service to emerge, because now you need to go and build something that's custom for that particular purpose.
Sure.
Now for Grid, that Dan talked about in the prior episode, that if you haven't downloaded and heard that yet, you should certainly do that.
Mm-hmm. Definitely. That was show 1478, published September 21st.
So for that, we had yet another challenge. And the challenge is that we're now doing a push to a function or to a webhook. But again, we have a reliability problem there. It's a different reliability problem, because it's not that the connection breaks, but that you're pushing to a target, and that target might be overloaded, unavailable, et cetera, et cetera. Right. So we have queues also in that new thing, but so in that push system that holds messages for 24 hours while we're trying to go and deliver that message.
Right,
In the ideal case, the message gets into the system and gets pushed out within a few milliseconds. But in the case that target is unresponsive or gives us a too busy error, we have to go and keep it. And so that gets stored durably, reliably, replicated in that whole fabric. And that's something that you'd never see, because you think of a push thing as being something that's straight through, but it's not. But that required yet another completely different thing to be built.
It sounds so logical and reasonable when I hear you explain it, the differences, but how do people figure this stuff out besides listening to you speak?
So we're trying to educate.
Yeah.
I have a bit of a taxonomy. So let's start with the intent. Or let's start with what a message is and why you send it. And then maybe we can work out how that maps to various services.
Okay.
So I try to make that easy. A message can hold. You send that with some intent. You can group those messages. You have commands, you have requests, you have queries, you have jobs that you hand off to someone and assign them. You have transfers of control where you have done a piece of a workflow and you hand that off over to the next microservice that does that. You have facts you report. You have log info that you write. You have events in the sense of discrete activities that happen that you want to go and report out.
Well, there's a lot. As Paul Simon said, there must be 50 ways to send a message.
Yes, and there certainly are. So we can put some structure on this. And there's two broad categories. There's one category that we can call intents, which you send with an expectation that another party fulfills some contract. The other party is doing something. So you send a command and you expect that something happens. You transfer control and you expect that something happens. It may not feed back to you, but you're expecting that action is taken based on the message that you sent.
Right.
So these are, let's call them intents for a moment. The other things are all facts that happened in your system that you simply report out.
Right.
You report them out to create transparency and to also provide the ways for others to extend the functionality that you're already providing. But you have no expectations that something happens.
Yeah.
So
you don't know who's listening. And you're not responsible for who's listening.
Yes, and you don't care.
Right.
And with intents, like a transfer of control, you may also not know, like as the program may not know
Who's
receiving it,
Right.
but the system owner who configures the system will know.
Right.
With an event, the system owner may not know initially,
Sure.
but then may go and add things later.
And
But
that's part of the strength of that model, right?
Yeah.
Is that it is very tolerant to modification.
yes, so you have so first split is intents, facts.
Right.
So intents is what I call broadly messaging. That's all service bus territory.
Right.
And then there's some of that in IoT Hub where you have, you send commands to devices, you have these interactions, but again, 10 million queues.
Yep.
So IoT Hub is very special because of that scale point.
Right.
But the rest of all the intense messaging, I would say, is mostly service bus territory and then obviously also logic apps territory because they do workflow coordination and all these things.
Right.
And then that's the other part is the distribution of facts. And events are messages that carry facts. Events are facts in motion.
Yeah.
Those also fall into two groups. You have discrete events that tell you something, like a light bulb on, off, discrete activity. Then you may measure, since we're talking about light bulbs, the temperature of the light bulb, how healthy that thing is. Temperature, vibration are kind of the base sensors that you use for health of pretty much everything.
Physical things.
Sure.
Yeah.
Physical things. And so a single data point, a temperature data point is useless generally.
No.
What you want is you want to have a trend. You want to see how that thing behaves and how the temperature develops. Like vibration data, obviously a single data point helps you nothing.
You want deltas.
You want deltas, and you also ultimately you want to have a trend. You want to have an average. You want to see the behavior of over time.
A stream of data. Yeah.
So discrete events are very different from these series events, and it also causes you to have a different architectural approach to those.
Sure.
With discrete events, let's go to the data series first. The data series has context. It comes from a certain light bulb, and it's time-bound, typically. So you want to have a series that's ordered by time, and then they're all interrelated.
Yeah.
If you want to do analysis, you need to go and pull them into a process that can go and keep state. It can go and have a time window, and then you can go and calculate over that time window, which means you need to go and pull that data towards you.
Yeah.
And that is what Event Hubs does. Event Hubs gives you, and Kafka does that too. Event Hubs gives you a tape drive pattern, effectively. You can push the stuff, and it's a tape drive that you can write to and read from at the same time. So it's, but from the read perspective.
People listening, what's a tape drive? Can you hold that thought right there? We need to pause for just a minute to hear a word from our sponsors. This portion of .NET Rocks is brought to you by our friends at JetBrains. Hey, how often do you profile memory usage in your .NET apps? What if you could automate memory usage checks so that they're executed every time you commit a change? You can actually do that with .memory unit from JetBrains. .memory unit is a free unit testing framework for monitoring .NET memory usage. You write unit tests that check your code for all kinds of memory issues, and then run the tests on your machine or in a continuous integration server like TeamCity or VSTS, just like you do with regular unit tests. You can track how much memory is allocated, check memory for objects of a specific type to prevent memory leaks, or compare several memory snapshots in a unit test to see if memory usage is creeping up. Learn more and download .memory unit from jetbrains.netrocks.com, or just search for a package called .memory unit on the NuGet Gallery.
And you're listening to .NET Rocks. Richard here, hanging out with Carl and Clemens. We're in London at ProgNet, talking a little bit about all the messaging, all the ways. And you mentioned just before the break, Kafka. And I'll include a link to it because it's in the Azure Marketplace. Why would I be interested in this? Like, what does this give that I don't get out of all of the various hub options that are already in Azure?
Event Hubs does effectively the same that Kafka does.
Okay.
The difference is really in the protocol.
Oh, all right.
Okay.
So this is about being adaptive to existing systems that are already depending on Kafka. Kafka's Apache Foundation, I think, right?
Yes. Yeah. So if you have a lift and shift application that you want to bring into Azure and you are depending on Kafka and that proprietary protocol that it uses, then use that.
So here's this thing you can add in, and now you're eating Kafka messages, no problem.
Yes.
You can bring them into the hub.
Yeah. So what we've done very clearly is we've committed to open standards.
Yep.
And for us, the send gesture into a service bus or event hubs is the same because we use AMQP as the standard protocol for both. Mm-hmm. And consuming is also an AMQP gesture from on event hubs. Mm-hmm. And the gesture is effectively the same from receiving to service bus. Right. There's just some extra filter thing where we have that all completely documented. With Kafka, you're kind of depending on this very specific Kafka protocol that's there. And if with that dependency.
And you're saying AMQP as in advanced messaging querying protocol?
Yes, the AMQP 1.0 protocol is what we use, and then we also obviously support HTTP.
Well, and you've been part of helping work on that specification too.
Yes.
So you were talking about the two different kinds of events. The data series event lends itself well to event hubs.
Correct.
So let's talk about the static.
Yeah. So the discrete events are different because they occur less frequently. Also because they are not dependent on each other. So you don't need to have a stream. You don't need to look at the event before it and after it to make sense out of it. So they lend themselves to a different handling.
Right.
So you have a device and the device raises an alert and it's a very specific one. Then you will want to have an alert handler that deals with that specific event.
Mm-hmm. Is that a service hub thing I would do then?
That's a grid scenario.
Okay.
So, and I said device, it could be anything.
Yeah.
Right?
Device is a very open term these days.
Yes. But okay, so let's use a backend thing. You have a sales support application. In the sales support application, you have a discrete thing happening. And let's say that is new lead created.
Right.
So that's a clearly distinct event. It's a state change inside of that app.
Yeah.
Mm-hmm.
So you turn that into an event you raise into the event grid. Mm-hmm. You can react on this. And this may happen, depending on how busy your company is.
Sure.
Once every hour, or could happen, once a day.
Right.
And let's say you have a tactical application, a tactical extension for your app, for that sales lead app, where you want every new sales lead that you have in to be invited to a conference that's happening in 2 weeks.
Right. So you're sort of kicking off a workflow of what does that conference invitation look like?
Yes. So with Event Grid now, you can go and create a handler. You can create an Azure function. You can create a logic app.
Right.
And you can hook that up right into that event that you publish out of your app.
Nice.
Yeah.
And it will be called when that sales lead event is fired, but it's a push, which means if it's an Azure function, you have this tactical extension to your application sitting there as an Azure function costing you nothing.
Yeah, unless it's needed.
Until it's until it's executed. So if that happens once or twice a day, you pay for 2 executions. But you don't have to have a service running that runs all the time, that pulls on a queue, that listens to an event stream. You don't need to do any of those. And it's very targeted because they're singular events. So you can go and filter by the type of event. And you can we have some further filtering capabilities that you can use to really home in on a specific event that you're kind of interested in.
Sure. I'm just thinking about this from a manual point of view, right? You're an organization, you're going to run an event. Like I said, 2 weeks from now, we're doing this event. I'd like any new leads that come in, any sales that get made. I want all those people on that list.
Yeah.
Now you tell an assistant, this is your job now. And so it's like every afternoon, they're going through checking to see, have we signed up any new people? What sales came through? Have they already been added to the list? Like you spend money on a person trying to sort all that data out.
Yes.
Or plugging into this event model. That's not very codey either. It's just this little drop-in workflow so that the moment you engage, it works. And it's very timely. Somebody makes an order, order confirmation comes in an email, and right after that is this invite. Hey, why don't you be part of this thing? It's a better business and cost effective.
So what Dan will have explained is in the previous show that you should listen to is, for instance, being the triggers that you can do on a blob. Right? So upload a file, you trigger on a blob, and then you call a function. The function downloads the blob. If it's a JPEG file, you have a function that recodes it and drops 5 different sizes in a different directory.
Yeah.
Automated.
Awesome.
Easy.
Right. Yeah. Super easy. And these are these discrete events which you handle very differently. So because we have these serverless infrastructures now, where we have these infrastructures who listen for you and where you don't pay for the listening. Where you deploy a function into that infrastructure which does all the listening for you and you don't pay until it executes, we have now made this special new thing. This is now the not service bus thing. Prior, this would have been a service bus topics job.
Which is like swatting a fly with a Buick, right?
Yeah. So these discrete events, you now can go and subscribe to them and activate that code whenever it happens. And that yields a very nice extensibility model for the system. And the system being two things. A, think of Event Grid as a eventing tier that we put under the Azure platform. So you don't subscribe on Event Grid. You actually walk up to storage when you go and want to subscribe. You subscribe to an event from the storage container. So Event Grid is actually getting out of the way completely.
Right. Yeah.
But for your own applications, if you want to write the custom topics, anything that is one of these discrete events, a discrete state change in your application, you can go and now publish an event out of. And you can go and hook into that event. And that's a suddenly natural extension mechanism. So you have a...
And you should be noted that those can be in completely separate applications.
Totally different. They can be in another data center because we just push out to an HTTPS endpoint.
Right.
So you can think of it as a core of your application. That's what the application focuses on as a day-to-day thing. And then you can go and basically put extensions on the side of that. Super, super easy.
Yeah.
And so the storage system doesn't do conversion of JPEGs.
No.
But your function that you're hooking into it now does conversion of JPEGs. So you're extending the capabilities of the storage system, and that's a way you can go and look at it.
Right.
So that's super powerful. But that also motivates. So this distinction between discrete events and series of events, that motivates why we have event hubs and now Event Grid.
Right. I get it.
And then we have these intents, which I put on the side, and that's why we have Service Bus, because Service Bus remains the Swiss Army knife. Like if those two things don't fit, Service Bus is always to drop the fallback.
Yeah.
It's always the safety that you always use for all other cases.
Hey, Richard.
Yeah, buddy.
Guess what time it is now?
It must be that happy time again.
Yep. It's time to filter out all the discrete events raised today when the humor level went above 1 laugh per hour. And here's the result.
I think my message queue is empty. Oh my goodness.
It's actually time to give away a D-Experience subscription from Developer Express to one lucky member of the .NET Rocks fan club. Become a UI superhero with DevExpress UI controls and libraries and deliver elegant .NET solutions that address customer needs today and leverage your existing knowledge to build next-generation touch-enabled solutions for tomorrow. Whether it's an Office-inspired application or a data-centric analytics dashboard, DevExpress Universal ships with everything you'll need to build your best without limits or compromise. And check out their DevExtreme React Grid, built from the ground up to fully support all the cool features that come with React, like the virtual DOM and state controllers like Redux. It supports master detail, sorting, grouping, paging, and editing. You can check it out and test it for free from GitHub. And learn more and download your free 30-day trial of DevExpress Universal at devexpress.com/superhero.
All right, buddy. Who's our winner?
Today's winner, guys, is Alexander Rosenberg.
Congratulations, Alex. Golf clap for you, sir.
And Alexander just won the D-Experience subscription, a big pile of awesome from our friends at DevExpress, just by signing up for the .NET Rocks fan club. And if you don't know how to do that, go to .NETRocks.com, click on the big Get Free Stuff button, answer a few questions, and join the fan club. We have thousands of members all over the world, and every show we like to give away stuff from our sponsors. And every December we give away a $5,000 technology shopping spree to one lucky member of the .NET Rocks fan club. But you have to sign up to win. Clemens, it's your turn. You've done this before. If you had $5,000 technology spending money, let's go shopping. What are you buying?
Oh, wow.
I'm going to pick camera gear for you because you always want better pictures of airplanes.
Well, you did airplane stuff before.
See, I would 5,000. I would probably want to see whether I can get a from the boneyard.
Tour of the boneyard?
No. I did tours of the boneyard, but whether I could get I want to have a B-52 instrument panel for my office. That would be a great thing.
The backsplash of your desk as a B-52 flight panel.
Just on the wall.
Hook some of those dials
Those
up
gauges
to real things, like like from Azure Event Hubs, for example.
Yeah, that would be pretty awesome. But that's
powering the dash.
Powering the dashboard, but it's got these, for this. Does that count as technology?
Absolutely, absolutely.
It's got these sets of 8 different sets of gauges for the the engine
For all the
readings and
engines,
all.
yeah.
So it's this massive.
The old TF-33.
The most fabulous Museum of Flight in Seattle
Very fabulous.
has a B-52G that they're now, they just started renovating it, restoring it.
Right.
It's been sitting outside at Payne Field in Everett for a long time. And so now they're painting it, then they're going to take it apart and truck it down to Maine Museum where they're setting up a site.
How much are they going to put in the museum? Like just the cockpit or the...
No, they have the whole thing.
They're going to put the whole plane together inside the building.
No, not inside the building. So they have a special space. So they built this aviation pavilion, which is a large lot with a roof now on top of it. And right behind that, they have a special space where they're going to put that. And they can't put it indoors because based on arms limitation treaties, all the intact B-52s need to be visible outside.
Interesting.
Yeah.
Of course,
Yes.
right. That's part of the...
That's why it had to sit at Payne Field outside the whole time
to be visible.
And so the Air Force flew it in and then cut all the cables so they couldn't fly it anymore.
Right.
So the museum had to pay for the last 8 years they had to, or 10 years they had to go and pay for that slot on the main field because their own site was not big enough for that thing.
Well, I remember, one of the things in the treaty, I can't remember which one it was that they actually were getting rid of B-52s and they would lay them out in the boneyard and they would take these big shears, cut the wings off, lay them beside the plane in a particular pattern so that when the Russian satellites went over top, they could have pictures of this is a disassembled plane.
They'd still sit there. If you look up Tucson on
Google Maps.
Thank you for saying that. And look, they are all still, or many of them are still sitting. My point was, I had the chance in 2011 to actually get into that plane.
Oh, wow. The one at Payne Field.
And then kind of see that whole dashboard and all that. So on my Flickr account, I have some
it's
pictures
the
of this.
8-gauge block, that center engineering block. I just want to know what to get you for Christmas, my friend. Like,
so that's the piece that I would love to have.
Because I'm just pulled up a picture of it because, internet. And it's a big piece. Like that's a lot. They each have a separate firelight. So there's 8 firelights there. And it'd be interesting. Of course, that whole panel is pretty large, right?
Yeah, in the Museum of Flight in the Red Barn upstairs, they have one of those panels sitting there. In the B-52 exhibit, so that's
something to get that to Germany.
I don't know, but that's if you come into my home office from which I do most of my work, you would not be able to tell them I'm a computer person. It's all
aircraft.
It's all airplanes.
Yeah. Well, a number of times you and I have gone back and forth while you're touring something or other and argued various aircraft because the angles I care about too, right? Boundary plate flow areas and the details of what make an airplane.
Yeah.
All right. So I'm trying to figure out if we've actually covered all of the hub bus options here. So the IoT hub, certainly the very wide, simple scaling event handlers. We've talked about Event Grid a bunch of times. Certainly Service Bus as the catch-all. This is the master tool then. Azure Event Hubs, Azure Notification Hubs. So have we really explored those two?
So Event Hubs is we talked about the Kafka and
and that falls into the Event Hub.
Event Hubs is really that's what I talked about as serious. That's default all Event Hubs. Like if you have log style information, if you have readings from systems, then Event Hubs is the way to go. If you have data from all kinds of different systems, like in gaming, what happens on the multiplayer map, things like this, anything that's contextual data you want to go and analyze in bulk, that's all Event Hubs. And that's why we currently do 5.1 trillion operations per week.
Wow.
Event Hubs. And it's used across a number of industries for all kinds of, and it's all telemetry that's coming in.
So I got to think for most people listening to the show, you probably want Event Hubs when you talk about those essential messages moving out. That's
so let's.
Well, wait a minute now. How does IoT Hub and Event Hub work? Do they work together? Is IoT
they work together.
So IoT Hub is the sucking up of the data and queuing it to Event Hubs? Is that how it works?
So IoT Hub is a very specialized service that is for attaching devices and device gateways into the cloud.
Right.
And when I say devices, I mean typically bespoke devices that are not phones or tablets or common information technology devices, but stuff that lives out in the world.
Right.
Cyber physical systems, as they say today. Cars. And so that's very specialized for that. So
And where does it go after it goes into the
Yeah,
IoT hub?
some aspects of that. So some of that data that comes in is serious event data. So that goes into blends in IoT Hub, and IoT Hub has a compatible endpoint that looks like Event Hub. So it's, for all intents and purposes, it's an Event Hub.
Oh, okay.
Then there's other data that comes out of the devices, which is more discrete character, and then they have IoT Hub routes that can go and then spew that out into, let's say, a service bus queue.
Right.
Okay.
So you can go and then catch that from there.
The service bus then offering up the transactionality, the multi-stage, those more complex capabilities.
Yes.
And then if you have data-based, analysis-based triggers, then you would maybe raise an event or call an Azure function from that.
Yes, you can. But let's explore that, like the distinction a little bit more.
Sure.
So IoT Hub is specific for these IoT. That's why it's called that way.
So it's like an Azure hub that's got an IoT face on it.
Yes. Yeah, you can think of it, but it also has bidirectional capability. So it's really special for those kinds of devices. Event Hub is a more generic foundational capability that applies to a much broader set of use cases. It applies to that, but it also applies to very many other things. Gaming, finance, anything you like.
All these log streams.
And that's why we have, as I said, 5.1 trillion transactions.
Clearly people agree with you.
Is a lot. The Service Bus has roughly 700 billion transactions per month.
Okay.
So that's, you see the difference is that Service Bus is a little bit heavier weight, I would say, and for interactions. Notification Hubs is a service that we built that's specialized in a way where we needed to have pops up fan out through other people's messaging systems.
Okay.
Namely Apple's notification system, Google's cloud messaging for Android, to Kindle and to Baidu, where we basically do push notification distribution into all of those. So there the challenge was, like the last Olympic Games were in Sochi. And so they built an app where they wanted to allow people to know exactly when an event ended and what the result of that was and all this. So they ended up having 25 million apps that subscribed for these notifications. And so they could send one message, and then we would make sure that we could go and replicate that one message as fast as we could, and then push it out through 25 million distinct channels.
Or distinct channels with many different devices, different protocols too.
Yes. So
they're pumping out one message and just have an architectural demand for this is where it needs to go. Here are the subscribers. Go.
That's powerful.
And you guys took all the weight on that.
Yeah. And so that's a yet another completely different pattern, which is a different PubSub engine, because it also needs to target different things. And then the last one and the bit odd one is it's the Azure Relay service.
Okay.
And all of the other ones that we talked about are datagram oriented.
Right.
A datagram is a set of bytes that's clearly finite.
Right. And a stream is I want to keep an open connection, and I'm just going to continue to send datagrams.
Well, send and receive too.
Send and receive,
It's a very common scenario, specifically with SaaS applications, that you have small and medium businesses which are using a service, but they have like their businesses on site. Tax accountants, lawyers, medical clinics of all sorts, point of sale, restaurants, all of these, where you want to, from the SaaS application, want to have some integration where you can call that on-site app. And you want to ask it something, so you can go and make a decision and tell something to your application. So you can't wait. Like you get a request and you walk over there, you go and get some information, you show that up to the client that sits on your mobile gateway. Let's put it this way. The relay allows you to bridge into that app, no matter where it lives, with a application level socket connection. We have a new feature called hybrid connections that allows you to make a WebSocket. And we have Logic Apps, which has an on-premises data gateway. And there's the app service, which has the hybrid connection manager. And both of those allow either tunneling web service requests through this, or you can go and do a database connection to an SQL Server or Oracle database. So you can go and reach into other, out of the cloud environments, and the relay is facilitating that through NATs and firewalls. And we deal with transition through the proxies and all that
Sounds very Signal R.
Signal R for stream.
So Signal R for stream.
But I was about to say WCF.
Yeah.
Yes, but it's the reverse. It's really the reverse direction. We allow you to put up a service listener from anywhere, and you expose that service listener onto the client. And the relay is literally the oldest feature of Azure.
Right.
Wow.
We made the first public preview of that available on May 31st, 2006.
Wow. And I remember thinking back, this is when we were first talking about Azure, we were talking about the challenges of between data center, between organization, WCF messaging. Getting through NATs and firewalls and, you know, all of those restrictions. And it was so hard to go point to point. Like you had to have IT involved. They were negotiated sockets and so forth. All of a sudden, this relay, the fact that we'll both agree to talk to the cloud. The cloud will either facilitate the transaction itself or facilitate the connection for the transaction.
And it's so this literally started as an incubation in the WCF team.
Right.
And we still have a WCF variant of that. That's very super popular because no matter how many people are not liking it, it still is in the enterprise landscape.
Sure.
Yeah. Many developers pick up WCF because it does what it does. It does that well.
Yes.
And if you are staying on the straight path of saying just make a service contract and
we demand transactional integrity. We want end-to-end control. We want rollback.
That it's good enough. And yes, you can go and shoot yourself in the foot, both feet, very easily by going into the Netherlands of
the inner
of the configuration nonsense.
We love the Netherlands, please. Dutch, don't write us. That's not what we meant.
I meant the Netherlands.
Nether regions.
The Nether regions.
The Nether regions. Sorry. Yeah, I meant that.
You can get far enough under the hood of WCF, you will never come back, right?
Yes,
like it is the endless.
That's
it
what
is
I
the
meant.
endless force.
Yes. I live 10 minutes from the Dutch border, so I hope they don't take that.
There you go.
So for that, the relay still has a WCF binding, and it's make it super easy.
The opposite of that is you do everything as through a web transaction, and now you're trying to do your own transactional integrity. Like it's this game where I've got the beast that is WCF, and this ultra lightweight. We're just going to do it with REST kind of mindset. And it's like, but I need rollback. Welcome to the beast, my friend.
And you need some queuing, and you need all that other stuff.
So, but the new relay is now hybrid connections, and that's a super lightweight, WebSocket based. You don't need anything. Handshake. You can do that super easily with Node and with JavaScript out of the browser, even if you want to.
Nice.
There are no requirements. The protocol took a long time to have the minimal set of gestures.
Right.
So you can go and create this bidirectional WebSocket bridges, which are now very friendly to either put some text protocol on top of, or you go and create binary streams, and then all the other things that are not mentioned, so logic apps and also the hybrid connection manager, they basically layer on top and give you a virtualized TCP connection.
Now, it goes without saying, and I just want you to confirm it, that all of these things are using HTTP and can be therefore use HTTPS just with a bit flip, right? I mean, we can do everything you're talking about here securely. Is that true?
We do secure by default. We don't even have a non-HTTPS option for any of these things.
This is one thing I really love about Azure lately. If you create a new website on Azure, and you just go to HTTPS, whatever that website is, and it just works.
Yes.
And we're not far away from an HTTP doesn't work.
Right.
Yes.
Like you're required to be secure all the time. Google's busy sending out messages right now to unsecure sites, saying to HTTP only sites, going, by the way, you're basically going to we'll still search reference you, but when they click on you, we're going to give them a warning that you're not secure.
And rightfully so.
Yeah, because it's time. The certs are free. It's time. I got to fix run as.
That's right.
Yeah, but so we look at these services that we have as a fleet. Relay is kind of the odd one because it's not a datagram service, but it's a foundation for other capabilities that are like logic apps layers on top that then moves datagrams across it. And we'll also have some other integrations in mind coming that will go and right on top of that. So it's a basic building block. But then you have the other services, Event Grid for discrete event distribution, Event Hub for serious event series. You have Service Bus as the universal thing, and you have the highly specialized services, IoT Hub and Notification Hubs. And that's kind of a family of capabilities that we have, and we're not quite done yet, I think, because what we find from customers is there's always something else. There's always another special case.
Right. It's got to get large enough that it's worth building a specific
scale dimension.
Yes,
well, that's a good question. I mean, at what point do you not make an edge case a feature of an existing system and actually spin it off to its own?
When it will rub the system in a way that it will impact the performance of the mainline use cases. So it used to be all service bus and features of service bus. So there was service bus, queues and topics, and the relay and event hubs, and it was all in one thing. The problem that we had and that we solved in our quest to get, like, we're running all the services. So event hubs, for instance, runs at about 5 nines of reliability right now.
99.999%.
Better than the internet.
Which is pretty remarkable.
Yeah, that's amazing.
And to get there, we had to make the workloads as uniform as we could make them.
Sure.
Which means you cannot allow one aspect of the service to start taking capacity away from the other part of the service. So we had to break them apart, and we made service bus its own thing, relays its own thing, and event hubs is the same, it's its own thing, and event grid is the same, is its own thing. So the criterion for when you make a different service is when you need to have a different architecture.
Yeah.
Right.
And for, as I explained, the event grid is a very different architecture from what event hub is, and from what service bus is, and from what all the other things are. And in the different services tiers, like we have service bus standard versus service bus premium.
Right.
Premium gives you predictable performance. And you don't pay per transaction, but you pay for capacity reserve inside of the system.
Right.
That is so different. And so the pricing model is different, but also the underlying architecture is different.
Sure.
The Service Bus Premium is a completely different underlying architecture and implementation than Service Bus Standard, even though they look exactly alike.
From a coding perspective.
From your
But
programming model.
it's the SLA change, right? It's like
The SLA change is what makes it. So you pay more for premium, certainly because you pay for the capacity. So initially.
You're building a reservation.
Yeah.
Yes, but you get a very predictable performance because that capacity, the memory, and the CPU and messaging is the funny thing. It's not an IO bound service in Service Bus. It's really it's a lot of work that needs to happen. That is reserved for you, and that's not the true in standard. In Service Bus Standard is all shared capacity. It's all multi-tenant, and if someone gets super busy, then it can affect you, and that's completely impossible in premium.
Right, and that's why what I love is you build it running on standard, and then when you see that you have SLA issues, right? Whatever service you're delivering,
or you're anticipating them.
There's a product you can move to without any recoding. It's literally an account chain.
And that was something that was purely driven out of customer need and demand and feedback, because we had, in some cases, very large customers in e-commerce for Black Friday. We had to go and just make a cluster, take all of the namespaces that they had, just corral them into that one cluster so that they could have a uniform workload that we could go and watch that. And that was...
See, I can see that you guys have this advantage of being able to see all of these workloads as a whole. Like I know when you need a new product, when you can see that your existing product is straining under the comprehensive workload it's given.
Yes.
Right.
Not any given customer's problems.
Yes.
All customers together problems.
That's right.
So it's the advantage of the cloud that you get that view.
Do you ever intervene and see what a customer is doing, see the kind of data that they're putting up, and they've used the wrong service?
Yes.
And you say, you really need to do this.
Yes, we do. It rarely happens that an external customer does it, but internal Microsoft teams have done that, where we have famously in the development of Halo 4, they've started doing some load tests against Service Bus. Event Hubs didn't exist at that point, so they didn't. On a Saturday, they did load tests against Service Bus in a very particular way, and that cluster just keeled over.
Pinned it. You're kind of proud when you pull that off, too. Right? Tipping over a rack is a good day.
And so we were like,
how did that happen?
Where does that come from? And so we looked that up and we're like, okay, this is...
Don't do that.
So I literally called the Halo people up and said, whatever you're doing, stop.
Bad devs.
I can imagine, too, because you have so many different products in Azure and services, and some things come out and they're new and shiny, and they have... like I'm thinking Cosmos DB, for example, right? I mean, you can pay to have the kind of latency that you typically get in a messaging service, and yet it's a database, but you have triggers. So you could use that as a sort of a messaging service, an expensive messaging service, and, but perfectly happy to do that.
Yeah.
But that's not what it's for.
Yeah.
We're learning out of all those things. Like incidents like that don't happen twice.
No.
Because we learn from them.
Sure. The question is, should they use a different service as a service communicated a different way, or it's like, you need to code this differently?
Yeah. So there's two things that happened in that particular case, or two learnings out of this. Like first, service bus is not the right pipe for that kind of problem.
Right.
Yeah.
That was one of the motivations for making event hubs, actually.
Right.
So the gaming scenario drove event hubs.
Yep.
And then the other one was that their usage surfaced a bug in our system. That was, it's distributed systems, bugs are weird.
Subtle.
It was a perf bug that was just amplified by this, and then caused ripple effects in the whole system. So that's
that cascading tip, right? Like,
so that's something that we ended up fixing. Yeah, I mean, the service bus standard, the storage engine is a little prone to these, or has been a little prone to these issues. So that's something that we then fixed. So we took two learnings out of that episode, and that was first, we got to go and fix that bug.
Right.
And the other one was, we actually really need to have a different service for these scenarios.
Right.
So Halo 4 was the motivation, one of the core motivations to go into.
And clearly, many more people have jumped onto it because it does serve a particular style that is of architecture that's useful.
Yes, absolutely.
Trillions of transactions.
Well, I don't know about you, Richard, but I feel completely clear about all of these things.
I'm remarkably enlightened.
Yeah.
Like, I feel really good about, because we look at this going, my concern is what was legacy in this? Like, you guys just building new stuff and leaving the old stuff behind for the folks that used to use it. But I come out of this going, I don't feel like anything's legacy.
No, it all works
Even
together.
the relay service, which is arguably the oldest thing, is still important, has a purpose, is the correct choice on a greenfield app today, given certain requirements.
Yes, we only have retired one feature so far, really, and that was the message buffers, which were the little in-memory queues that we had before we had a queue, that lived alongside the relay. That's the only thing we really retired.
Interesting.
Yeah.
The rest is all additive, and they're all complementary. And with the event grids, and specifically, we make them all really come together. Like, if an idle queue goes from having no messages to suddenly there's a message, it will raise in the grid event so that you can go and have the serverless thing, then walk up to the queue, drain the queue, do all the work, and then go to sleep again.
Right.
Love it.
So we'll go and combine those things, and we'll keep them growing if we have a new thing that generally.
And you'll see it before we will as customers.
Yeah.
You as the cloud owner see this broader picture of everybody's utilization to see where new features essentially or new products essentially emerge.
Yeah. So if we from our team announce a new feature or announce a new service, that does generally not mean that we're superseding, retiring anything. It's it's literally a new use case, and we're innovating. We're not following anybody.
Right. And it's based on need. You're not
because it's based on need.
You're not speculating at all. You're looking at what people are doing and finding a way. And it occurs to me, you've been here for the whole thing, my friend. Like, we've known each other a long time.
Since the
I
days
remember
of
you
soap.
joining Microsoft and you wanted to work on this. Like, you've been here the whole way.
I have shipped 7 of these things.
Wow.
I remember famously talking to you at a PDC. It was probably 2002, 2001, right around the beginning of .NET. And we were trying to get web services to return collections.
Right.
And Clemens said, no, don't do that. Use arrays. It's like, yeah, duh, right? It's just one of those simple things.
Yeah, I actually started in the .NET community. My first public talk was at Tech at Europe 2001.
Yeah.
And it was about SOAP.
Yep.
Right.
So I've been a messenger. I mean, of the other stuff before that.
You've been
but
messaging
actually,
a
no,
long
2000.
time.
It was 2000. Tech at Year 2000. And that was a talk about SOAP right after Don Box gave a SOAP keynote. So that room
In a
was
bathtub.
full. 850. I had 850 people in my first talk.
Nice. No pressure.
No pressure.
Clemens, it's been enlightening to the max. Thank you so much.
Thank you for having me. It's always a pleasure. I will be happily coming back in whenever we ship the next thing.
It's been, I mean, it was a year and a half this time around, my friend.
Yeah.
Since January 2016. But clearly there was plenty to talk about. You know, There's always that question. It's like, how many times do you get to talk about messaging? Well, let's tell you, messaging evolves. Like, stuff's going on.
It does. It does.
Great. Thanks again, Clemens. All right. We'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Pwop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got transmitter banned by the FCC. Yes, I'm a toy boy. Life is hard.